We don't study history, we make it. What a line, right? And the guy who said it, the physicist I Rabi, well, he lived up to every single one of those words. This is a man who didn't just observe the 20th century, he was one of its chief architects, helping to write its most brilliant and, yeah, its most terrifying chapters.
So you gotta ask, how does one person have that much of an impact? I mean, it's one thing to change how we see the universe, but he took that knowledge and changed the world with it. So let's get into the incredible story of I Rabi.
Now, Robbie's journey, it doesn't start in some fancy, pristine laboratory. No way. It starts in a tiny Polish shtetl. He came over to America as just a baby back in 1899, and his family landed right in the middle of the bustling, Yiddish-speaking world of New York's Lower East Side. And for a kid with a curious mind like his, the local public library was like a portal to another universe. And one day, it literally was. He grabs an astronomy book and discovers the Copernican system. For him, that clean, beautiful logic of planets circling the sun, it was a complete revelation. It basically set him on a totally new path, pulling him from the religious world of his family straight into the world of science.
I mean, this one story just tells you everything you need to know about young Rabi. For his bar mitzvah, a super important religious ceremony, instead of giving a traditional speech, what does he do? He gets up and delivers a full-on lecture, in Yiddish no less, on how an electric light bulb works. You can just see him, right? Already trying to build a bridge between the world he came from and this new world of science that he was just so fired up about.
And here's the thing, if you wanted to become a physicist back then in America, you kind of had to do it yourself. This whole revolution of quantum mechanics was exploding across Europe, but American universities, they weren't even teaching it yet. So Rabi and a couple of his buddies, they just taught themselves. They'd spend their Sundays poring over European journals until he could finally get himself over there to learn directly from the legends. We're talking Bohr, Pauli, and Heisenberg. So when he gets back to Columbia, Rabi is laser-focused on the heart of the atom, the nucleus. Now, a lot of people were trying to figure it out by just smashing atoms apart, brute force. But Rabi had a much more elegant idea. He didn't want to smash it. He wanted to, in his own words, gently tickle it to make it talk. Of course, an elegant idea like that still needs cash to make it happen. And this is where the story gets really cool. A fellow Nobel winner, Harold Urey, does something amazing. He takes $8,000 from his own prize money and just gives it to Rabi. Think about that. That $8,000 was the seed money for what would become the legendary molecular beam laboratory. So what was this revolutionary method? It's called nuclear magnetic resonance, or NMR for short. The core idea is kind of genius. You use a combination of magnetic fields and a very specific frequency of radio waves to, tickle an atom's nucleus. And when you hit just the right frequency, that resonance frequency, the nucleus actually flips. And that little flip, that's how it tells you its secrets. The setup itself is just beautiful. Okay, so imagine this. You shoot a beam of atoms through one magnetic field. Then you hit them with that perfectly tuned radio wave. And finally, you use another magnetic field to detect which atoms had their states flipped. It's this brilliant, indirect way to measure something that's, it's impossibly small. And what made this a true game changer was the insane leap in accuracy. The older method was kind of like trying to weigh a feather in a hurricane. That brute force magnet just introduced way too much noise. But Rabi's resonance method, that was like listening for a specific musical note in a silent room. By finding that exact frequency that made the nucleus sing, he could measure its properties with an accuracy nobody had ever seen before. And yep, that's what earned him the Nobel Prize in 1944. But right when Rabi is at the absolute peak of his scientific career, the world just explodes into war. Suddenly, the pure science he was pioneering gets yanked out of the lab and thrown onto the battlefield. And Rabi himself gets pulled from the ivory tower into a brand new role, a leader shaping the technology that would decide the fate of the free world. So in 1940, Rabi literally just shuts down his lab, puts all that Nobel-worthy research on hold. He moves to the brand new MIT Rad Lab to work on a game-changing piece of tech from Britain, the cavity magnetron. This device was the absolute key to creating microwave radar, which would prove essential in the war at sea and in the air. Rabi learned pretty fast that he wasn't just battling technical problems anymore. He was fighting military bureaucracy. And he had this really strong view on it, famously insisting that scientists couldn't just be on tap, like hired help. No, they had to be on top, strategic partners sharing leadership to be truly effective. Now, even though he was a close friend and advisor to J. Robert Oppenheimer, Rabi kept the Manhattan Project at a bit of an arm's length. He believed radar was more critical to the immediate war effort, and he was just deeply troubled by the moral abyss the atomic bomb represented. He was there, though. He was there in the New Mexico desert for the Trinity test. And his words from that moment, they just capture this profound sense of awe and dread. He understood in that single blinding flash of light that science had lost its innocence. It had given humanity this new, terrifying power over its own destiny. And that moment in the desert, it really transformed him. In the post-war world, he dedicated himself to making sure that the immense power of science would be used to build bridges, not just bigger bombs. And man, the guy did not waste any time. He took that big science model from the war and applied it directly to peace. Check this out. 1947, he co-founds Brookhaven National Lab. Just 3 years later, he proposes a joint European lab, an idea that turns into CERN. Then, after Sputnik, he convinces President Eisenhower to create the President's Science Advisory Committee. He wasn't just doing science anymore. He was building the global infrastructure for it. There's this great little story that just says so much about who he was. His friend, President Eisenhower, casually refers to him as a university employee. And Rabi gently corrects him. "Mr. President," he said, "the faculty are not employees of the university. They are the university." For Rabi, that was a core belief about the absolute importance of independent scholarship. Okay, so we come to the end of this remarkable life, and this is where the story circles back in the most incredible personal way. It connects his most abstract work to a profoundly human application. Near the end of his life, an ailing Rabi was taken to a hospital for a scan. The technology they used was magnetic resonance imaging, MRI. And what is MRI? It is the direct medical descendant of his fundamental work on nuclear magnetic resonance from 50 years earlier. Can you imagine? He's lying there, inside this machine, and he had this epiphany. All those years of tickling atomic nuclei, just chasing pure knowledge, had led to this. A machine that could see inside the human body and save lives. He was, in a very real way, seeing his own legacy. So, what is Rabi's true legacy? His life really presents us with two powerful models. Is it the single brilliant discovery of NMR? Or is it the institutions he built, like CERN, which created a whole new way for the world to discover together? A specific breakthrough, or a new path for all breakthroughs to follow? That's the question his remarkable life leaves us with.